Hello, today I'm going to show you how to create a simple application based on PSOC Creator. First of all, we need to download the IDE, go to Cypress.com and search for PSOC Creator. It will bring a couple of links. In this case, as I'm using Windows, I'm going to download this package. It's about 680 megabytes. The installation is quite straightforward. It's quite simple. And this is the file that you should see once you download the package. Here you can see the ecosystem. I'm going to work with the PSOC Creator installed in my laptop. We're going to use the dongle that comes with the BLE kit to snip the packets, and we're going to have 3 boards. The main board that you can see with a couple of small boards based on 42, 48, and the 11573. Both are different kind of hardware. And in this opportunity, we're going to choose the 4248. Once you open PSOC Creator 4.0, you have to go to File, New Project. Choose the right microcontroller according to your hardware. In this case, I have the 4248. This is a small board that comes with the BLE kit from Cypress. Next, and then you will find a couple of options. You can choose a code example and a lot, well, several examples. Find me heart rate, ID, keyboard, mouse, router, etc. Or you can choose to create an empty schematic and write from the scratch an application. I'm going to do that, and we're going to create the whole schematic. In this case, we're going to create as well the workspace and the first project of this workspace. In the future, you can add more projects to this to the same workspace. Okay, I'm going to call BLE test. We're going to add this inside of the schematic different type of peripherals. You can see on the right inside of the component catalog 2 tabs. Cypress and of chip. Inside of Cypress, you can take a look at analog, where you can see ADC, amplifiers, DAC, communications. You will see the I2C, SPI, Bluetooth, cap sensors, touch, components to control LCDs, and so on. The next step is, in this case, I'm going to add the BLE by dragging and dropping this object. Once I added this component, double click on the component and you will see all the configurations for different type of features. Now I'm going to set up the BLE peripheral. In this case, I'm going to use a profile to run a Find Me application. That's why I'm going to choose Find Me. Here, there's nothing else to modify. Then I'm going to go to gap settings. The name of the device will be Find Me target. I'm going to choose generic hearing. That's it for now. Advertisement settings. Student mode general. Return request. Okay. The advisement packet, checking. I'm going to modify the service. Okay. Name complete. I'm going to set up the output power level and appearance. Okay. Then security is not going to have security in this case, but you can add it later. Modify the input output capabilities. On the bonding and the encryption size, it's okay. Finally, inside of profiles, I'm going to remove a couple of features that are not going to be used. Central address resolution and resolve private address. And that's it regarding BLE. Well, that's what I had to do regarding BLE setup. Now, I'm going to add a couple of digital input outputs. Actually, in this case, it's an output. I'm going to drag and drop 3 of them. And I'm going to double click just to modify deselect the hardware connection. And I'm going to name this output according to my needs. One of them is going to be the alert LED. Advertise and disconnect. Yes, I forgot to deselect. At the same time, in my case, I need to be sure that the initial drive state is high. Now, I'm gonna add 3 resistors. These components are only for descriptive purposes. They are not required for the function of the design. Okay. It's more like a schematic. Save as well. Schematic. Now I'm going to add a couple of, well, actually 3 LEDs and a power supply to finish the schematic. Okay. Good. This LED. Copy and paste. And then power supply. name, power supply, PLE, VDD, and I'm going to use the wire tool to connect every dot. Okay. Now I'm going to save this file and click on the design wire resources. You will see the 3 LED that we just created, and we need to assign pin port in the pin. In this case, we're gonna use the port 3, pin 6 and 7, and for the disconnect LED, the port 2. This selection of pins has to do with the evaluation kit. In your case, you can modify, you can choose any other pins. Inside of the design wire resources, we're gonna click on clocks, and we're gonna set up the internal main oscillator. This opportunity, we're gonna create a 12 megahertz clock. Let's save the file, and let's compile for the first time to see if everything is okay. Just click on project with the right button of the mouse and just build the project. You can see here the output of the process. Here you're going to see some messages. If you would like to see information about the RAM and the flash used by the process, you need to open the output window, and you can read the flash and the RAM used by the project. In the Workspace Explorer, you can see all the files generated by the compilation process, the LEDs and BLE libraries, necessary libraries to run the application. Okay, let's take a look at the main file. So you can see it's quite simple. Actually, it's empty. I need to write an event handler to run functions according to the state of the PLE. To do so, I wrote an application to have an event handler and to have as well an alert handler. So you can see here, this is the event handler of the stack. And then I have with different kind of states that the VLE could have. At the same time, there is an alert event handler, and well, the initialization of the VLE and the loop, okay, of the system. It toggle an LED depending on the occasion. I'm not going to talk in detail about it. The main function of this video is to help you understand how to work with PSOC Creator, and this is only an example. I mentioned in the beginning that you can download code examples. There are several and this is similar to one of them that find me. Okay, so I save the main file and I'm gonna compile again. It seems that everything is okay. Let's program the board. Go to debug, select debug target. If everything is okay, you should see the board that you plug to your laptop. Then you have to click on connect, and then you have to go to debug and program the device. You will see several messages on the screen that actually it should say the device was successfully programmed. To finish this project, we need to test the firmware. There are two ways to do it. One is to download the application based on Android in your cell phone. And the second one is to download the application based on Windows and use the dongle, which is what I'm going to do. Now you have to open your browser, go to cypress.com and enter CY8CCKIT042, which is the name of the application to use the dongle. Here you can see the dongle and the application. Open this link, download this file. Once you download the file, you have to see that it's a file about 47 megabytes. Well, now you have to install the application. Once it's installed, you have to go to the Cypress folder and write the CY8CCKIT042 application. Of course, that by now you need to plug the dongle. So you can see here, the laptop was capable to recognize the dongle. Click on connect, and we need to click on a start scan. So you can see here, the board was recognized. Click on this packet, and you can actually connect with it. That's all for today. I hope you can find this video useful. Thanks for your time. Bye.